Good morning, one and all. Myself, Dr. P.G. Andhare, Head Department of Mathematics, RBNB College, Srirampur, District Ahmednagar. Today, we learn sequence of real numbers. First article is definition of subsequence and sequences. Definition of sequences and subsequences. First we see definition of sequence. Definition of sequence. A sequence capital S is equal to S suffix I is equal to 1 to infinity of real numbers is a function from capital I, the set of positive integers into R, the set of real numbers. Set of real numbers. Here I is domain of this function and R is codomain of the function. I is set of positive integer, therefore I is equal to curly bracket 1, 2, 3 and so on up to n and so on. And R is set of real numbers. In some books, sequence is also defined as a sequence is a function whose domain is set of natural number capital N. Here we have taken I is domain, I is set of positive integer, therefore S, capital S operates on 1 is equal to S, small s suffix 1, which is first term of the sequence. S operates on second positive integer, that is 2, it gives S suffix 2, that is second term of the sequence. And so on. S in general, S operates on n is equal to S suffix n is the nth term of the sequence. Yes. And so on. For example, S is equal to S suffix n is equal to 1 to infinity, is equal to 1 upon n is equal to 1 to infinity. This sequence can be written as S suffix n is equal to 1 by n for all n belongs to I, that is set of positive integers. If n is equal to 1, we obtain S1. S1 is equal to 1 by 1. For n is equal to 2, we obtain S2, S suffix 2, which is equal to 1 by 2. For n is equal to 3, we obtain S suffix 3, which is third term of the sequence 1 by 3, and so on. S operates on 1, it gives S1. S operates on 2, it gives S2. S operates on 3, it gives S suffix 3, and so on. Thus, the sequence S is equal to S suffix n is equal to 1 to infinity is equal to 1 by n. N is equal to 1 to infinity. is equal to S1, S2, S3 and so on, Sn plus 1 and so on is equal to 1, 1 by 2, 1 by 3 and so on, 1 by n plus 1 and so on up to infinity. This is sequence of real numbers. Sequence of real numbers. Means sequence S is function from the set I of all positive integers into R set of real numbers. Set of real numbers. This function is into function. Now we see definition of subsequence. Definition of subsequence. Subsequence of positive integers. Subsequence or subsequences are denoted by S suffix n1, S suffix n2, S suffix n3 and so on. n1, n2, n3 all are positive integers. All are positive integers. A subsequence capital N of small n is equal to 1 to infinity, n is equal to 1 to infinity, which is equal to 1, 2, 3 and so on. A subsequence capital N of small n is equal to 1 to infinity of positive integers. Integers is a function from the set capital I, the set of positive integers into capital I, such that capital N operates on I is less than capital N operates on J if I is less than J for all I comma J belongs to capital I. A subsequence capital N of small n is sequence of positive integer, is a function from the set I of positive integer into I, such that Ni is less than Nj if I is less than J for all Ij belongs to capital I. For example, the set of the prime numbers 2, 3, 5, 7, 11 and so on is subsequence of sequence of positive integers. Second example, 2, 4, 6 even numbers and so on, 8 and so on is also subsequence of sequence of positive integers. Again, 1, 3, 5 and so on, order numbers, is also subsequence of sequence of positive integers. Now we define subsequence of sequence of real numbers. We define subsequence of sequence of real numbers. If S is equal to S suffix n is equal to 1 to infinity, is sequence of real numbers. Sequence of real numbers. And capital N is equal to n suffix I is equal to 1 to infinity, is subsequence of sequence of positive integers. Then since capital S is equal to Sn, n is equal to 1 to infinity, is sequence of real numbers, it is function from capital I into R, and capital N is equal to Ni, I is equal to 1 to infinity, is subsequence of sequence of positive integer, is function from I into I. Therefore, S composition N, then S composition N is called subsequence of sequence of real numbers. S composition N is called subsequence of sequence of real number. S composition N is function from I into R. S composition N operates on I. S composition N operates on I. Since capital N is subsequence of sequence of positive integers, capital N operates on I is equal to n suffix I for all I belongs to capital I. S operates on n is equal to small s suffix n for all n belongs to I. Now S composition N operates on I is equal to S of n of I is equal to S of small ni is equal to small s suffix small n suffix I for all I belongs to capital I. Therefore, S composition N is equal to sequence S suffix n suffix I is equal to 1 to infinity, is subsequence of sequence of real numbers. S is equal to Sn, n is equal to 1 to infinity. S composition N is subsequence of sequence of real numbers. S is equal to Sn, n is equal to 1 to infinity. We see some example. If S is equal to Sn, n is equal to 1 to infinity, is equal to 2n minus 1. N is equal to 1 to infinity. and capital N is equal to Ni, N suffix I is equal to 1 to infinity, is equal to I square for all I is equal to 1 to infinity. Then find S suffix 9, S suffix 5, S suffix 9, S suffix 5, N2, S N3, S suffix N suffix 3, S N3 is capital N subsequence of K, K is equal to 1 to infinity, is capital N a subsequence, is capital N a subsequence of small k, K is equal to 1 to infinity, K is equal to 1 to infinity. First, we calculate S5, S9, N2 and Sn3. Solution of this problem. Since we have S is equal to sequence Sn, N is equal to 1 to infinity, is equal to 2n minus 1, 2n minus 1, n is equal to 1 to infinity. This sequence can be written as S operates on n is equal to S suffix n is equal to 2n minus 1 for all n belongs to I. For all positive integer small n. Again, capital N, since capital N is equal to Ni, small n suffix I is equal to 1 to infinity, is equal to I square, I is equal to 1 to infinity. This is subsequence of sequence of positive integers. Capital N operates on I is equal to small n suffix I is equal to I square for all I belongs to capital I. Capital I is set of positive integer. This is say 2. Now we calculate S suffix n, that is S5. Put n is equal to 5. S operates on 5. Capital S operates on 5 is equal to small s suffix 5 is equal to 2 into 5 minus 1, 10 minus 1 is equal to 9. Again put n is equal to 9. S operates on 9. That is 9th term of the sequence of real number. S suffix 9, which is equal to 2 into 9 minus 1, 18 minus 1 is equal to 17. This is 9th term of the sequence of real number Sn. Again put I is equal to 2. Put I is equal to 2 in 2. Capital N operates on 2 is equal to small n suffix 2 and is equal to 2 square, which is equal to 4. Now we obtain subsequence of sequence of real number. Subsequence of sequence of real number. S is equal to Sn, n is equal to 1 to infinity, and S composition n is equal to small s suffix small n suffix I is equal to 1 to infinity is subsequence of sequence of real numbers. Therefore, S composition n operates on I is equal to S operates on capital N operates on I by definition of composite function. This is equal to n operates on I, it gives n suffix I. N operates on I is equal to small n suffix I. Capital S operates on n suffix I. S operates on n, it gives S suffix small n, which is equal to small s suffix small n suffix I for all I belongs to capital I. Therefore, S composition n is equal to S suffix n suffix I is equal to 1 to infinity is subsequence of sequence Sn, n is equal to 1 to infinity. That is, S suffix n suffix I is equal to S composition n operates on I is equal to S operates on n operates on I is equal to n operates on I is it gives small n suffix I. Value of small n suffix I is equal to I square, which is equal to S operates on I square. S operates on n, it gives S suffix n, which is equal to 2n minus 1. Therefore, this is equal to 2 into the element, that is I square minus 1 for all I belongs to capital I. Therefore, S suffix n suffix I, small s suffix small n suffix I is equal to 2I square minus 1 for all I belongs to I. Now we put I is equal to 1, we obtain Sn1, which is equal to 2 into 1 square minus 1, which is equal to 2 minus 1 is equal to 1. This is first term of the subsequence Sn. Again put I is equal to 2, we obtain S suffix n suffix 2, which is equal to 2 into 2 square minus 1. 2 square is 4 into 2 8, which is equal to 8 minus 1 is equal to 7. Put I is equal to 3. S suffix n suffix 3 is equal to 2 into 3 square minus 1. 9 into 2 is 18 minus 1, which is equal to 17. And so on. Sn1 is first term of the subsequence. Sn2 is second term of the subsequence. Sn3 we have to calculate. Sn3. Sn3 is third term of the subsequence. Therefore, subsequence S composition n is equal to, therefore, the subsequence, thus the subsequence S composition n is equal to S suffix n suffix I is equal to 1 to infinity is equal to 2I square minus 1. 2I square minus 1, I is equal to 1 to infinity. 2I square minus 1, I is equal to 1 to infinity, which is equal to Sn1, Sn2, Sn3, and so on is equal to 1, 7, 17, and so on. This is sequence of real numbers Sn, which is equal to 2n minus 1. Another question is capital N subsequence of k, where k is equal to 1, 2, and so on up to infinity. Here capital N is subsequence of positive integers. We calculate, put n is equal to, put small I is equal to 1 in 2 capital N operates on 1 is equal to small n suffix 1, which is equal to 1 square, which is equal to 1. Put I is equal to 2. I is equal to 2 into capital N operates on 2 is equal to n2 is equal to 2 square is equal to 4. Capital N, put I is equal to 3 into capital N operates on 3, n3 is equal to 3 square, which is equal to 9, and so on, and so on. Therefore, capital N is equal to small n suffix I is equal to 1 to infinity, is equal to 1 square, that is 1, 2 square is 4, 3 square is 9, and so on, and so on. This is subsequence of sequence of positive integers, sequence of positive integers, sequence of positive integers, or capital N is, or in other words we say that capital N is subsequence of k. K is equal to 1 to infinity. Capital N is subsequence of k. K is equal to 1 to infinity. Hence the solution. Now we take another example. Example number 2. Let sequence Sn n is equal to 1 to infinity. Let sequence S is equal to Sn n is equal to 1 to infinity be defined by S1 is equal to 1, S2 is equal to 1, and we have to defined by S1 is equal to 1, S2 is equal to 1, and Sn plus 1 is equal to Sn plus Sn minus 1 for all n is equal to 2, 3, 4, and so on. Find S suffix 8, that is 8th term of this sequence. Find S suffix 8, that is 8th term of this sequence Sn. First term S1 is equal to 1. Second term S2 is also equal to 1, and we have to calculate 8th term, and for this we have provided Sn plus 1 is equal to Sn plus Sn minus 1 for all n is equal to 2, 3, 4, and so on up to infinity. Solution: we have S1 is equal to 1, S2 is equal to 1, and the recurrence relation Sn plus 1 is equal to Sn plus Sn minus 1 for all n is equal to 2, 3, and so on up to infinity. This is say equation 1. Put n is equal to 2. Relation 1 is true for n is equal to 2, 3, 4, and so on up to infinity. Put n is equal to 2 in 1, equation 1. S suffix 2 plus 1, it becomes S suffix 3 is equal to S suffix 2 plus S suffix 1, which is equal to S suffix 2 is 1 plus S1 is 1, which is equal to 2. Again put n is equal to 3 in 1. We obtain 3 plus 1 is 4. S4 is equal to S3 plus S2, which is equal to S3 is 2 plus S2 is 1, is equal to 2 plus 1 is 3. Again put n is equal to 4. N is equal to 4 in 1. We obtain S5 is equal to 4 plus 1 becomes 5 is equal to S suffix 4 plus S suffix 3, which is equal to S4 is 3 and S3 is 2, which is equal to 3 plus 2 is 5. Again put n is equal to 5 in 1. N is equal to 5, 5 plus 1 is 6, S6 is equal to S suffix 5 plus S suffix 4, which is equal to 5 plus 3, it becomes 8. Put n is equal to 6 in 1. We obtain 6 plus 1 is 7, S7 is equal to S6 plus S suffix 5, which is equal to S6 is 8 plus S5 is 5, 8 plus 5 is equal to 13. Put n is equal to 7 in 1. S suffix 8 is equal to 7 plus 1 becomes 8 is equal to S suffix 7 plus S suffix 6, which is equal to S suffix 7 is 13 plus S suffix 6 is 8, which is equal to 21. S suffix 8 is equal to 21, which is 8th term of the sequence Sn. 8th term of the sequence Sn. Thus we write, and so on, and so on. Thus we write sequence S suffix n is equal to 1 to infinity, is equal to S1, S2, S3, S4, S5, S6, S7, S8 and so on, is equal to S1 is 1, S2 is 1, S3 is 2, S4 is 3, S5 is 5, S6 is 8, S7 is 13, S8 is 21 and so on, and so on. S1 is 1, S2 is 1. We calculate S3. Sum of first two number, 1 plus 1 becomes 2. S3. S4, 1 plus 2 becomes 3. Next term, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is equal to 21, 13 plus 21 is equal to 34 is 9th term of the sequence and so on. This sequence is called Fibonacci sequence. This sequence is called as Fibonacci sequence, and these numbers are called as Fibonacci numbers. Fibonacci numbers.